Hello and welcome everyone in another episode of Researcher Celebrity powered by Empowering Science Foundation. Today, we have an esteemed honor to have Dr. Michael Turell with us. Dr. Mike, a little brief about him. He has done his bachelor's and master's from Cornell University and PhD from University of California, Berkeley with Dr. Bill Reeves and Jim Hardy. Dr. Mike has been instrumental in origin of American Committee of Medical Entomology started in 1984. Dr. Mike is a medical entomologist and arbovirologist, has served US Army as medical entomologist for 5 years and as a civilian for 34 years at US Army Medical Research Institute of Infectious Disease, where he has done so many discoveries, research, and we will discuss about that with more than 200 publications, which were cited more than 10,000 times, which shows the impact of his research and his publications in the field. And then he has worked in the field of Costa Rica, Belize, Peru, Kenya, Uzbekistan, to name a few countries, and he has worked in many, many more countries. With this brief introduction, I would like to welcome Dr. Mike at the platform, thanking him for being our researcher celebrity for today.
Thank you.
So we always start, Mike, with our question that how and when you decided to become a researcher?
It's a difficult question. That as a child, I became interested in entomology at the age of 4. I just like creepy crawly things. So I went to college and I did not know, I wanted to be an entomologist, but who knows what kind. I got involved originally with apiculture, honeybees. Then the US Army joined me, and they made me from an apiculture person into a medical entomologist. They made me take a course in the epidemiology of disease, preventive medicine. And since I love solving problems, I said, wow, this is where I want to be. I want to be an epidemiologist who studies infectious diseases, particularly those diseases transmitted by mosquitoes, which basically got me involved in doing research. So I worked for the Army for another several years doing just general stuff in medical entomology, and then got got a Master of Public Health from Tulane University in epidemiology, and then my doctorate at Berkeley under Bill Reeves, Jim Hardy, looking at the epidemiology of vector-borne diseases. And it's really important to understand which mosquitoes transmit what diseases, what factors affect the ability of mosquitoes to transmit a disease. I should point out that there is no such thing as mosquito control. There's more than 3,500 known different kinds of mosquitoes. If you control, very, very few of those mosquitoes transmit disease. The mosquitoes that transmit malaria do not transmit Japanese encephalitis. Mosquitoes that transmit Japanese encephalitis don't transmit West Nile. The mosquitoes that transmit West Nile, I mean, these are all different mosquitoes, don't transmit chikungunya or dengue or Zika. So controlling one species of mosquito may stop one disease and may actually increase other diseases. So you really need to know for this particular disease, which mosquito do I want to control? Controlling the Aedes aegypti will have no impact on malaria. It may actually increase malaria. Controlling the Anopheles will control malaria, but may increase the amount of chikungunya or West Nile or Japanese encephalitis. So we have to know which mosquito transmits which disease and why to do it. I got involved in doing research because that's the way to get the answers to these questions. And I've been playing as a researcher for at least 40, 50 years at this point. Next question.
Nice. So now we'll take one step before your PhD. So you already had a job working as medical entomologist with US Army. What made you think to start the PhD at that time when not many people were driven towards PhD?
Well, I think by that point, I already realized I wanted to be a researcher. Having worked, just a little side note here, I've worked in the laboratory with many, many different people. Some people with a high school degree, some with some college degrees, some with a master's. I have yet to find anybody I did not learn something from. Every one of these people know more than I know about something. and particularly technicians, the low-level technician. They do the job every day. They see what works, they see what doesn't work. I know professionals who say, I have a PhD and I know everything. You are a technician. You know nothing. You do what I say. Those are idiots. I've dealt with them. Uh, every technician who's ever worked for me, I've learned something from because they spot things that the senior people never get to see. And I've changed the way things were done based on what the technicians told me. Now I've already forgotten your question, but that's besides the point. Go back to what was the question again?
The question is not when you started and when you decided to do a PhD at that time,
Okay, so
getting the jobs, you already had a job and still chose to do PhD.
well, when I got out of the army, because I didn't want to stay in the army my whole life. So at that point, to get the PhD, in order to get a job directing research and doing interesting science, I was interested in mosquitoes and viruses and disease. And Bill Reeves was the #1 person in the world. So I applied to Berkeley, and much to my surprise, I got accepted. And once I got accepted at Berkeley, I got my doctorate in the epidemiology of vector-borne diseases. And then Charlie Bailey, who's actually the founder of the American Committee of Medical Entomology at USAMRIID, said, hey, Mike, why don't you come do a postdoc with us? Because we could really use you. So I came to USAMRIID and said, wow, this is fun. I get to do cutting edge research on some really bad viruses. Most laboratories cannot work with some of the really dangerous viruses, and USAMRIID had the facilities to work with the bad, nasty ones. We didn't bother with dengue because any laboratory could work with dengue, but we worked with things like Rift Valley fever, Venezuelan equine encephalitis virus, some nasty viruses, Japanese encephalitis. These are viruses that are much more dangerous and much more greater potential to cause major outbreaks. And the Army has known for years that up until very recent times, many more soldiers died from disease than died from enemy action. So the smart Army says, forget about killing the other army, protect your army from disease, and you will win the war. You had many, many more deaths from disease. You could stop disease, you win the war. So the Army started doing preventive medicine projects, and I got involved with that to find out which various diseases in Africa, South America, Asia, these diseases were affecting American soldiers. They want to know, how do we stop it? It's sort of like you have a fire in your next door neighbor's house. It's not your house. Why worry about it? Let your neighbor worry about the fire. Well, if you do nothing to put that fire out, your neighbor's house will burn down, and then your house catches fire. If you help your neighbor put the fire out in their house, the fire is put out and your house is not burned down. If you have tropical diseases pick a continent, and you say, well, that's not the United States. I don't need to worry about that. That's somewhere in South America or in India or in Africa. Not my problem. Well, those expand, and pretty soon they are my problem. If I can put the problem out and control the problem there, I help people who live there, and I reduce the risk of those pathogens coming to the Americas, to Europe, or African diseases making it to India, or Indian diseases making it to Africa. With modern transportation, that's going to happen. So I just got involved doing research because I like solving problems. Absolutely. I got the PhD because I thought it would help me be more in control of what I could do.
So now, over 3 or 4 decades of that time, how do you see the PhDs at that time and now what is going on and happening, especially in terms of entomologists? So Dr. Tiadak, my PhD supervisor, used to say that race of entomologists is going to be, this species is going to be extinct soon, because now everybody wants to be sitting in the air-conditioned room and do all the research on molecular stuff so that they don't have to be in 100 degrees Fahrenheit plus, and then humidity is 70%. So people get killed because of those heat waves. And So now coming back to you on this question, that the entomologists, the degrees, the research 3 decades ago in entomology and currently.
Okay, first of all, when I was a 4-year-old, my goal in life was to go to Africa, go to the Gambia River and see the animals, go to Peru, go to the Amazon River and see the animals. That was what I wanted to do in life. By looking at mosquitoes in the Amazon area, we knew that there was an outbreak of Venezuelan equine encephalitis. We were interested in it. We set up a study in the Amazon River, right by the Amazon River. Now, you can set traps out there to catch mosquitoes. Unfortunately, those traps catch mosquitoes that are attracted to mosquito traps. They don't necessarily catch mosquitoes that bite people. If we're worried about a disease affecting people, the mosquitoes that go into a mosquito trap don't count. Mosquitoes that bite people do. So we did what's called landing collections, which are much more difficult to do now than they were 30, 40 years ago. And you basically find a log out in the jungle, sit down the log, roll your pant legs up, and I'm going to get back here for a second. You roll your pant legs up and you sit there and you let the mosquitoes land on you. And as they land, you catch. I've had lots of people working for me doing this. And just a short digression, we were doing a study on a dengue vaccine, and they wanted to find out the Food and Drug Administration, before they approved the vaccine, wanted to know, could mosquitoes become if you vaccinated a person and that person has a very low level of viremia, could a mosquito become infected? So they were doing a study. They wanted to feed mosquitoes on the vaccinees. And I said, that's fine. But if you're going to ask them that question, ask them, thinking we feed mosquitoes on you, is that an ethical question? Remember, you are paying the, quote, volunteers. These are often people who need money, so they volunteer for this study so they can get paid. And of course, if they want to do the study, they have to let mosquitoes feed on them. So they're not really volunteers. So I said, okay, I will help you do the study. But before we even start this, I have a bunch of containers of mosquitoes with me. And each of you will feed mosquitoes on your arm. Because if it's ethical to do this to your quote volunteers, then you're volunteering right now. And if you won't do it, I won't be part of the study. So I had every one of the administrators feed mosquitoes. So now I said, when they ask you, what does it feel like? You can tell them, when I fed mosquitoes in my arm, it wasn't pleasant, but it wasn't that bad. When I do the landing collections, we hired people to do it. But before we hired them, I went out in the field and I did landing collections. I've done landing collections in Peru, Ecuador, Costa Rica, Belize, Senegal, Kenya, Thailand, Korea. I've done landing collections all over the world. Unfortunately, most of the people I've worked with have come down with malaria because we're getting hit by these things. I've been very fortunate. I have not knowingly come down with any of these diseases. But part of this becomes when you have to know what you're doing and you have to know how to do it safely. And I've always dreamed of being in the jungle. They paid me to go to the Amazon jungle 16 times in Peru. Now, of course, it's a little warm. It's not a little warm. It's hot. It's humid. It's nasty. Mosquitoes are biting you. For some people, you could not pay them enough money to do this. This was my golden life. If all goes well, and I retired 8 years ago. If all goes well, this summer I'm going to be down in Panama in a field study out in the middle of nowhere looking for Madariaga virus, South American Eastern. These are, to me, really important to understand what's happening with these viruses, because I'm trying to get some of these viruses, I want to make them go away because I don't want them to expand. And all of a sudden, look at what happened with chikungunya in the Americas, Zika in the Americas. Look what's happened with the reemergence of malaria, killing 600,000 people every year. And it's millions upon millions of deaths when we virtually eradicated malaria 60 years ago. Mm-hmm. We need to know what causes these. And I'm perfectly willing to do some stuff that is not necessarily pleasant, but it's fun. It gets me exposed to stuff. And I've gotten to meet cultures I was an invited guest in the Soviet Union back in the early 90s. I was an invited guest in China in 2019, and I've worked in all kinds of countries. Uh, and I have found that if I go there, I'm an American. Please treat me well. They should slam the door in my face. I'm here as a guest in your country. What should I do? What should I not do? What are the local cultures? What is the appropriate thing for me to do? What things should I not do? Things that would be acceptable in the United States that are not acceptable here. And I've learned all kinds of amazing cultural things by travel. I have fun. I should point out that my poor wife is not as much of a traveler as I am, but I have dragged her to Peru, Ecuador, Costa Rica, Kenya, Thailand, and a bunch of other places. Sweden. I spent 6 weeks trapping mosquitoes in Sweden, including landing collections. I mean, that's what I do. Part of this is we have to solve problems, and that's critical. Does that
Absolutely.
answer the question?
Yes, and this brings us to the next question of our conversation about you just briefly touched upon re-emergence of mosquito-borne diseases in United States. Now, I would like to ask your thoughts on the role of entomologists in vector-borne diseases, especially when they are researching. So people, as you said, that we thought that we get rid of malaria 6 years ago, 60 years ago. Like in Sri Lanka, there is again resurgence. Anopheles stephensi now is present in Africa and doing havoc. So the basic entomologist who can identify the mosquitoes, then to understand their crosstalks with the pathogen, their role in understanding a vector-borne disease which either was not there or was not there for a longer time.
Two things. One, I'm just sort of mention right at the beginning of this. I have heard many times in recent years about as global climate change, as the climate warms, tropical diseases such as malaria, dengue, yellow fever are going to move north into the United States. It's nonsense. If you look at the United States in the 1700s, early 1800s, yellow fever was a common disease. There are over 100,000 recorded deaths from yellow fever in the United States. There was a small outbreak in 1793 of 5,000 deaths in the southern city of Philadelphia. There was over 1,000 deaths in a single outbreak in the southern cities of New York and Boston. And I should point out those cities are not in any way, shape, or form southern. Those are northern cities. Malaria was a very, very common disease. During the American Civil War, the Army of the United States keeps track of disease. They recorded more than 1.3 million cases of malaria in Union soldiers. There weren't a million soldiers. The average soldier caught malaria more than once. The southern country of Canada, countries keep track of death. Malaria was one of the top 10 causes of death in Canada. These are not tropical diseases. These are diseases of the tropics, primarily of lower socioeconomic status. If you look at the United States in the late 1700s, nobody had electricity, nobody had running water, nobody had screening, nobody had windows. They didn't exist. The people living in rich homes in the United States in the late 1700s were living with servants, but pretty much the same as people living in the tropics today, or parts of the tropics. As you improve the standard of living, these diseases disappeared. If we can improve the standard of living in certain parts of Central South America, Asia, and other parts of the world, Africa, these diseases will go away. But how do we improve the standard of living is the problem. That's completely a side talk from the entomologist stuff. Now back to the entomologist. As I mentioned earlier, there is no such thing as mosquito control. If you have a disease such as West Nile virus, when it was introduced into the United States, it was in the papers every day about this new deadly disease was crossing the United States. Look out for mosquitoes because they bite you, they will kill you. You will die from West Nile. Put on repellent. Put on long sleeve shirts. Avoid mosquitoes. Don't die. It was all over the place. You go forward 20 years and it's avoid other people because you don't want COVID. It's in the papers every day. Uh, but there's this whole big thing about avoiding mosquitoes. In an area, there was an area where they had two areas that were very similar. They had really good mosquito control in one area and regular mosquito control in the other, trying to stop West Nile. What they found was where they did regular control and killed most of the mosquitoes, but still had a bunch of nasty mosquitoes out there, there was very little West Nile. In the area where they did really super good control, there was more than 3 times as many cases, more than 3 times as many deaths from West Nile virus as where they did poor control. The problem is, if you have Aedes vexans, which is an annoying, painful, biting mosquito that does not transmit West Nile, if there's still some there, the people say, oh my goodness, mosquitoes, I don't want to die, put on the repellent. And they avoid Culex tarsalis, which is the vector. In the area where they did really super control, they controlled Aedes vexans. Because they controlled Aedes vexans, the people said, wow, those mosquito people, they killed all the mosquitoes. I don't need to wear no stinking repellent. I can wear my short sleeve shirt and enjoy myself. Of course, that evening, the Culex tarsalis bit them. They got West Nile and died. You have to know which mosquito to control. You cannot control all the mosquitoes all the time. You can't control any species all the time. You have to know when to control a species and which species to control. The entomologist will tell you which species this is, the biology of that species, so you know how you can control it. For some mosquitoes, you can modify the environment slightly and the larvae can't survive. You get rid of the larvae, the mosquito is gone. The big thing for yellow fever, dengue, chikungunya was back in the in 1901, actually, right? They realized that Aedes aegypti transmitted yellow fever because they had a lot of civil military law in a lot of places. They said, by God, we're going to go inspect your house. If you have a container that can hold water, you're going to get fined, even if there's no water in it. If that container could have held rainwater, you're going to get fined. If there's water in that container, it's a bigger fine. And if there's mosquito larvae in the water, in the container, at your home, you're going to jail. Almost immediately, they eradicated yellow fever because everybody turned every container upside down. Today, because yellow fever is not a big problem, and people don't understand that those containers are what allows the mosquito that transmits Zika, dengue, yellow fever, chikungunya. It's all one species. If you turn those containers upside down, that species goes away. If you have screening and air conditioning and running water, it's much less of a problem. If you're in an area where there's no running water, you have to store rain barrels. Well, those rain barrels are the perfect habitat for Aedes aegypti. So the question becomes one of how do you keep the Aedes aegypti out of your rain barrel? And there's various different methods, from some chemical methods to screening. If you put screening over the top of the rain barrel and you keep the screening there, the mosquitoes can't get in to lay eggs. And if the eggs do get in, the mosquitoes can't get out. So you just have to make sure that you don't produce more mosquitoes. The entomologist can tell you which species transmits which disease, what is the behavior of the larvae, what's the environment of the larva for that species, and maybe you can modify the environment slightly to make it less hospitable for that species of mosquito, and you reduce the disease. Another really short story is during World War II, the American troops in the South Pacific were very worried about malaria. They took an island and they realized that in the tank trails going across the island were all these puddles of water. And those puddles of water were full of Anopheles mosquito larvae. And malaria was one of the big problems. And they realized that in those puddles, which were mostly shaded, all of the Anopheles larvae were in the shaded part. None of them were in the sunny part. So they realized, the Anopheles likes shaded water. It does not like sunny water. So they had all the soldiers go along these paths. You couldn't get rid of the puddles. but they cut down all the bushes that provided the shade. So all these pools were now full sun. And very quickly, the number of Anopheles went way down. It was about this point in time they also realized that while there was malaria, it was not as bad as they expected. There were lots of Anopheles, but very little malaria. Well, after a couple of weeks, they noticed there was a different Anopheles species that was a sun-loving Anopheles. And it now just took off because there was a lot of sunlit water. Unfortunately, the sun-loving Anopheles was the real vector of malaria. And malaria was so bad that the US soldiers abandoned the island. By doing the control, they made it so much worse. That's the type of thing where entomologists could tell you, yes, this mosquito like shade or like sun, but be thankful you have so much shade because the sun-loving one is a much worse mosquito and it's more dangerous. So the entomologist provides a lot of critical information as far as which mosquito transmits which disease. If you wait until you have disease transmission before you start controlling the mosquitoes, it's too late. Not only are people getting sick, but a lot of people have been bit by an infected mosquito. They're incubates. So even if you control the mosquitoes, they're still going to get sick because they've already gotten sick. You need to control the mosquitoes before they start transmitting disease. Is it rainfall? Is it doing surveillance for mosquitoes and seeing how many mosquitoes are out there? And if you have this many mosquitoes out there in a trap, then you start spraying. Do you do sentinel chickens where you put chicken flocks out? Do you bleed cows and look for antibody? And when you get a certain antibody level, you know the transmission is occurring. And then you do intensive mosquito control of the species that transmits that disease. So,
speaking of vector-borne diseases, specifically, like now we are talking more of the mosquito-borne diseases, but now I would like to know your experiences plus thoughts and guidance for the importance of surveillance.
as I just said, surveillance is critical. If you don't know, very bad things will happen. Starting control after the human disease or after animal disease is occurring on large numbers is way too late. You don't put the fire out after your house burns down. You need to put the fire out at the first time if you have a smoke alarm. As soon as there is a fire started, you put it out. You don't wait until the house burns down. By doing surveillance, and surveillance can either be straight collecting mosquitoes, how many mosquitoes do we have by species, and for certain diseases, you know which species to look for. Say, if this species is above this level, we're at risk for that disease. But this other species, this other disease. So depending on which mosquitoes are out there, you might control those mosquitoes because if those get above a certain level, we are more likely to have disease. In many places of the world, they do sentinel chickens. They'll have a chicken. I know in California, the government would give free chickens to people. You take care of the chickens. We'll give you chickens and food. You take care of them. We'll come by once a month or every other week. We'll bleed the chickens. We're going to test them for antibody. And we're going to bleed them on Monday. And actually, we're going to bleed them on Saturday. But we're going to test them on Monday. By Tuesday, we know what the antibody level is. So we know whether or not there's disease appearing in the area. This is way before you get human disease. So if the chickens become infected, you know the virus is being transmitted. If the virus is being transmitted, you start a control program. You can also do just bleed cows, bleed horses. You just bleed. Bleeding people is a little bit more difficult, but they've done that too. But that's already too late because the people are infected. The people are infected. You want to find out when the disease is starting to be transmitted and stop it before you get critical animals, i.e. either domestic cows. If you have a disease like Rift Valley fever, you want to stop it before the cows get infected. For Eastern equine encephalitis, you want to stop it before the horses get infected. If you can stop it before the expensive animals get infected, these way pay for themselves. A little short thing on this is that a study by Ken Linthicum on Rift Valley fever, he looked at El Nino years and heavy rainfall causes flooding. The flooding hatches large numbers of mosquitoes, including eggs that are vertically infected with Rift, and you get these huge outbreaks every 10 to 20 years. And I was with him, and he had predicted a rift outbreak in Kenya. And he wrote a paper that, given this prediction of rainfall over the next 6 months, we're likely to have a rift outbreak 4 months from now.
Mm-hmm.
He went to Kenya to look at the outbreak, and he couldn't find one. He said, I know there should have been an outbreak here. What happened? The rainfall was exactly as predicted. Some idiot in the Ministry of Agriculture in Kenya read his paper. They spent a bunch of money, they got a bunch of vaccine, and they vaccinated all the cows.
Mm-hmm.
And because the cows are the amplifying hosts for this, goat, cows, and sheep and goats were the amplifying hosts, they vaccinated them. There were no amplifying hosts. The virus just died out. There was no outbreak. They stopped the outbreak because of the prediction of the outbreak. And I am just shocked and amazed that Ken has not stood on this. Look what we did. We stopped it. We saved hundreds of thousands of cows. We saved hundreds of millions of dollars. We saved a whole bunch of lives. No, it's just like, well, no outbreak.
See,
now, if you go to Tanzania, where they didn't listen, there was an outbreak.
this is what now is very important. So people always talk about nip the evil in the bud. This is something which our researchers have already been doing it for so long, are doing right now. But now let's talk about the challenges as a researcher you have faced in so many different countries and the experiences which you would like to share.
Okay, challenge is one, as I mentioned, different cultures have different things. You have to live with the local, whatever is the accepted in the local culture, you have to live that way.
Mm-hmm.
If you are going to certain countries, and certain, we're not talking of a major city in a country with Hilton hotels. We're talking of closer to the jungle, and I have stayed in hotels where the hotel was 99 cents. That's 99 U.S. cents a night. You know something? It wasn't worth it. I upgraded my room to the $1.50 room, and that was much nicer. But you are living under conditions that are not always pleasant. So that you have to deal with. You have to live. You're traveling away from home. You're out in the field. When we were doing mosquitoes, we want to know what time of day mosquitoes were biting. We were trapping mosquitoes, doing the landing collections. We did those collections 24 hours a day. We want to know which mosquitoes, what for this species, does it bite at dawn, noon, mid-afternoon, dusk, evening, late at night, and different mosquitoes. What are the principal biting mosquitoes? By far, the worst time of day was noon.
Mm-hmm.
Start at dawn, they end at sunset, but the peak was at noon. They were a day biter. Other species, we never caught one between dusk and dawn. They're only at night, with peak times about 10 o'clock at night. So depending on when you want to do control, you have to know all that stuff. But to do that, we did our collections. We started every hour on the hour, collected for 40 minutes, rested for 20, collected for 40, rested for 20, and we changed people every 12 hours. So I was out in the field at 6 o'clock in the morning and 6 o'clock at night helping to exchange people. We had to spend 10 to 12 hours a day identifying the mosquitoes. If we had a 16-hour day, we worked 16 hours that day, boy, was that a short day. That was great.
Mm-hmm.
We had 18, 20 hours. We had days that we worked 18 hours. So you work very hard. But let me rephrase it. I never worked hard down there, ever. I just played hard.
Mm-hmm.
I got to do stuff that I enjoyed doing. If you do not enjoy hard work under field conditions, this is not the job you want. The bigger problem I've seen recently is administration and rules, particularly safety people. When I started at USAMRIID, the U.S. Army Institute, 40 some odd years ago, the safety people were basically semi-retired researchers. They had worked for 30 years. They didn't want to spend that much time in the laboratory anymore, so they became safety experts and provided guidance to the younger people how to do the work safely, which is critical. And they had done this job themselves for years. They were very good. The modern safety people are all academically trained. They know all the rules. and they've never been in a laboratory in their life, but they know the rules.
Mm-hmm.
And some of their rules are so unbelievably dangerous. They sound good. If you don't know, if you've never worked in a laboratory, you would not realize how dangerous that is. But they are in control of all the researchers, and you have to follow their rules, even if they're dumb, stupid, and dangerous. That was part of the reason I retired 8 years ago. Was I just got tired of following dangerous, stupid rules. Uh, you needed safety people who had worked in the laboratory, who understood why this rule is made. Oh, there's my wife in the background. Hi, Barb. You're on screen.
Hi.
Okay. So that's one of the real challenges these days is dealing with safety, working long hours, but it's all part of the job. One of the real short digression on this is I do a lot of work with youth groups, and I think it's critical to expose youth groups to science. We're talking 6-year-olds.
Yes.
And there's some really, really good scientists who are 6-year-olds. And I explain to them, find something you enjoy doing, work really, really hard to get really, really good at it. Get all of the education that you can. I mean, bust your butt, work really, really hard, and you'll never, ever have a job in your life because somebody will pay you a lot of money to do your hobby.
Absolutely.
For 35 years, they paid me to do a job I would have paid to have done. They sent me all over the world. Next question.
Now, this is something which I'll just say that, like working all those odds, working away from home, odd working hours, 18 hours a day, like more than double the time which most of the people do in one day.
Yes.
Everything went you going till now and you are doing great now. The question is, how different research has now turned after getting all those rules, quote unquote, clearances, biosafety, ethics, everything.
It's made it more difficult. And I've been retired for 8 years, so I've not had to deal with most of those things. However, I am working with people in a couple of different places to try and do good science, because I think good science is critical. And fortunately, they're the ones who are dealing with all those silly rules. And they're just having to find a way to, how do you move a mosquito from Peru to the United States? That part of my work in Peru, we had 3 questions we were trying to answer. Question number 1, which species of mosquitoes are found in this country? When we started that study, there were, in that region of Peru in the Amazon basin, there were 29 species of mosquitoes known to exist. 4 years later, there were over 100 species known to exist, with voucher specimens for all 100 species in the Smithsonian, all provided by us. So we documented, if you don't look, it's not there. There's lots of mosquitoes there. Second, we wanted to know what pathogens, what viruses were found in these mosquitoes. So we would take the mosquitoes, we would catch thousands of mosquitoes a night, we'd identify the species, pool them by species, put them on dry ice, take them back to the United States where I'd grind them up and test about 700,000 of them in that study, 700,000 mosquitoes, and see which viruses would I find in which mosquitoes, and found which viruses. And this virus is Eastern equine encephalitis, now called Madariaga virus, was found almost only in Culex pedroii. Different viruses were found in different mosquitoes. So depending on which disease we were worried about, different mosquitoes were the important mosquito. And we want to know which of the mosquitoes that were there could transmit which of the viruses that were there. So that was another set of studies. Now, to do this, I had to bring back 600,000 dead mosquitoes, 30,000 at a time. And then when I bring the mosquitoes back, we start isolating viruses. I now want to know which mosquitoes could transmit the viruses. So I needed live mosquitoes from Peru back into the United States. Even back in the 1990s, you had a lot of paperwork that had to be filled out to bring a live, potentially infected mosquito from the jungles of Peru into the United States. Well, I was very good. I went and got the USDA permits, got the CDC permits. I had all the permits, and I packaged everything appropriately and brought it back with me. Uh, we had a similar problem with people in Australia were very worried about Rift Valley fever because it devastates sheep. And sheep is a major industry in Australia. So they wanted to find out, could the Australian mosquitoes transmit Rift Valley fever virus? The government said, no way do you bring that virus into any laboratory in this continent. You will go to jail if you bring that virus here and do those studies. So I talked to the scientist there and he said, well, tell you what, if I ship you some mosquitoes, can you test them? I said, sure. Well, trying to get the mosquitoes from Australia into the United States, by the time I got them, they were dead. He tried 3 times and they died every time. So when he solved this problem, he invited me to a meeting in Australia. I went to the meeting in Australia, gave my presentation. They gave me a bunch of live mosquitoes. I put them in a container. I had to get permission. These are native Australian animals. You had to go to the Australian government and get permission to export these native Australian animals. If you're trying to export a kangaroo or a koala, it was the exact same paperwork for a Culex mosquito. Of course, the people I filled the paper out were laughing at the same time that we're doing this ridiculous paperwork so I can take a mosquito out to the United States and kill it. But we had, did we have proper medical care, proper housing? I had to answer all those questions. We did it, and yes, unfortunately, the mosquitoes in Australia were good vectors for Rift Valley fever. So if the virus got there, you would expect an outbreak. But dealing with all those things has become a royal pain. Next question.
Now, this brings us to the next very important question. So, research is not only what most of the people think is done inside the lab. Now, would like to know your thoughts on the importance of extension and outreach in research.
Okay. That when you're doing stuff, I know an awful lot about a lot of things. And like I said, I have yet to meet a person who does not know more than me about something. If I want to work on a project, I want to hire or work with or be associated with people who know more than me about various parts of the project. If we're doing a study involving PCR, yeah, I know a little PCR, but I'm not an expert in it. Mosquito taxonomy, I'm not a taxonomist. Mosquito biology, I'm not a mosquito biologist. My role has been coordinator to get all these people together so they can all put their 2 cents into this thing to come up with a great solution as to how to do the studies. I mentioned a little bit earlier, but I think it's critical that we train the next generation. Over the last 2 weeks, I've been working with a 4-H club, which is just like a youth organization in the United States, to teach these kids entomology. I was working with the Girl Scouts last night. I was with a youth educational program this morning, teaching entomology. In the Boy Scouts, they have an insect study merit badge. I try to encourage all of these kids to learn about entomology. Insects are not disgusting, yucky creatures. They're really neat, important things, some of which are important for food production, i.e. bees, and others are really evil creatures such as ticks, sandflies, lice, mosquitoes. They kill literally hundreds of thousands of people every single year. We need to know how to stop that. So that's all working with other people, extension. And back when I was in the Army, I was involved with extension. And people wanted to know, how do I stop mosquitoes? Is this creature in my kitchen? The pest control people said, I have termites. And it's going to cost me a lot of money to get my house treated for termites. It's unbelievably expensive. This was 50 years ago. They wanted over $1,000. I mean, it's a huge amount of money back then. And I said, well, unfortunately, termite control is very expensive. But do you really have termites? And they said, well, here's what they showed me was a termite. It was an ant. So I said, oh, buy an ant trap. It'll cost you $1. Put the ant trap there, you're done. Don't worry about it. But what I would do is I go to another pesticide company and ask them about termites. And if they say you have termites, show me one. And I will look at it and say, yes, that is a termite, and you have to spend the $1,200 to treat the termites. But if it's an ant, it's nothing. There is a real incentive for the pest control people to say, you have termites, or spray your backyard for mosquitoes. Doesn't work. But I get stuff all the time about control. Mosquitoes, there are a bunch of mosquitoes that will fly 20 miles or 30 some odd kilometers every night. So spraying your backyard will do nothing for the mosquitoes that are growing up 32 kilometers away from you. And of course, visiting your house for blood at night. Mm-hmm. You have to understand basic biology, and that's working with other people and getting that knowledge.
This is important when we talk about any disease which is vector borne or transmitted by a vector. But when people talk about researchers, specifically this has changed after COVID, that previously people were not acknowledging enough about the researchers, and part of our contribution, so Empowering Science Foundation believes in breaking the barrier, and one of the barrier is people don't acknowledge enough about the contribution done by researchers worldwide. Yes, things has been changed post-COVID. That is still debatable when it comes to researchers' acknowledgement. So we want to celebrate the research, and you have celebrated research for almost more than 5 decades. We would like to know...
almost more. I've done research for more than 5 decades, but that's besides the point.
So how you have celebrated the research and how you have seen that it should have been done, or in future, how you want to see that every person, be in any country, any continent, any field, should celebrate or start giving acknowledgement to researchers?
Well, two separate things. One, in recent years, there's been an awful lot of, should we call it pseudoscience? People claiming to be science, and it's not. Very poor, particularly with COVID, there's all kinds of craziness about various treatments for COVID that had no effect whatsoever on COVID. There was a side effect on the people. Lots of people died from those treatments. Or if you took 23 people with COVID and you gave them an anti-malarial drug and none of the 23 people died, therefore the anti-malarial drug treated COVID. That's true study, by the way. Absolute nonsense. If you take 23 people with COVID, the odds of any of them dying is very, very small. If I were to pat them on the head 3 times, that would work for treating COVID. More effectively than the malaria drug, I might add, because the malaria drug has side effects. This does not. Ivermectin, there's a bunch of these drugs that people are taking because scientists have said they work. And I don't know how you separate real science from pseudoscience, but that does bring up another topic, and that is publication, which you sort of mentioned earlier, that if you do a study, I was taught this literally 55 years ago. You do a study, you get some unbelievably important results, but you're busy and you don't publish them. The example he gave was you have found the cure for the common cold, which is unbelievably important, but you don't publish it. You never did it.
Yes.
Unless you get that word out to the public and actually published, it was never done. If you have interesting results, you need to publish them. You need to get them out. And I say this, and I still have like 4 or 5 papers from 10 years ago, which I have not published. I need to get back and get them out. But they're not as important as the common cold. The other one is you do a study. You get results. You did the study absolutely correctly, and you found out that the results are boring, completely uninteresting. Do you publish those data? Yes or no? Negative data. Do you publish them? Yes or no? Do you?
Yes.
It's critical you publish them because if you do it working at USAMRIID, I would have military people, scientists working under me or with me for 35 years. And they come up with this great idea for a study. And we did the study and it didn't work. So the data just dies because it's not important. A couple of years later, another scientist comes in, has the same great idea because it's a great idea. I said, no, don't do that study because it doesn't work. He said, how do you know? I said, because we did it, it didn't work. Well, how about we do this modification? I don't know, let's try it. Doesn't work. But if you publish that data to say it doesn't work, okay, the bigger problem is that's an important question to get to answer. You do your laboratory, it's not, and you don't get interesting results, so you don't publish it. Another laboratory repeats those studies. They get the same negative results. They don't publish it. Then another, you get it done at 6 different laboratories. It costs a huge amount of money to repeat that study over and over again. Everybody gets the same results. And everybody says, well, it's not interesting. It's sort of like testing. We're trying to find out which mosquito transmits a particular disease. You do the study and you find out the species A is a really good vector of this disease. You publish the paper. You do another study and you look at species B. And it's the only part of your whole study is species B, and it's a very, very poor vector, unimportant. Do you publish it? No, it's not important. It's not exciting. So you don't publish it. Well, another laboratory also checks species B. It's not important. Don't publish it. You have 8 different laboratories all doing the same study, nobody publishing it. You've wasted a tremendous amount of money when someone could have tested species C, D, E, and F and gotten much more important results if you have data that you did the study properly. I don't care if it's negative data, really interesting, really boring, you need to get the data published because it'll prevent other people repeating studies that don't need to be done. So I think that's really critical to get the data out there.
And this is something which we always talk about publications. You just touched upon it. And now it is like all over the world that there is this competition of publishing in the top tier, high-end journals, impact factors. And this also, again, has little bit, if not a lot, harmed the meaningful science because now it is driven by the journal where they want to publish. And then there are stories about whatnot, starting from data manipulation to images to whatnot. And then it ends up being retracted. This entire amount of work, people have reviewed it. People like you who have only 24 hours in a day and work which worth like more than 30 hours, and that is for every day. You spend number of hours in reviewing a paper which eventually has been retracted.
There's 2 things. There's one, high-end journals. Yes, I would much rather publish in a high-end journal than a low-end journal. That being said, if I'm searching for stuff, I'm searching on PubMed. PubMed doesn't care high-end or low-end. So if I publish the papers I'm looking at, I don't care where they're published. If they're published at a professional journal, I get maybe 1 or 2 requests to publish a paper in a journal every single day where it's a journal that sounds like, but isn't quite the right name for a journal that I know.
Mm-hmm.
They change the order of the title of the journal. So it looks the same, but it's not. These are fake journals. What they want is you submit the paper, they will publish it, and they want the money for they want the money to publish the paper. These papers are not available on PubMed because the journal's not real. I've actually caught one of these. I was a co-author on a paper, and they submitted to the journal. And I did a Google search on the journal. said, wait a second, that journal's not real. We pulled the paper that day. The journal wanted their money for publishing the paper. We said, but you never published it. But we still want the money. They said, no, you're not real. You have to get real journals, real publication. Uh, Personally, if it is a real journal and you publish it, high end is nice, but not important. It's important that you have a recognized journal that is recognized as being valid data. I once reviewed a paper looking at vertical transmission from the female mosquito to her progeny for disease in Egypt. And they reported the amount of time it took the eggs to hatch, the first instar turned second instar, second instar to third instar, third instar to fourth instar, fourth instar to fifth instar larvae, fifth instar larvae to pupae. You caught that, did you? They reported this to the nearest minute. First of all, no one has the data that accurate. Second is there are no fifth instar larvae. I mean, it's completely fake data. The data was completely fake. They made up. But if they had not put fifth instar larvae in there, how could you argue against it? You're claiming a degree of. When I see PCR, people put a CT value of 24.682. It's nonsense.
Yes.
20, that's 25. 24.682 is 25. Round to nearest whole number. You don't need any data beyond. I see plaque assay titers of 10 to the 6.832. No, 10 to the 7th or 10 to the 6.8. It's beyond the first decimal point is meaningless. I see all these things of people claiming percent infected. I see infection rates in paper all the times as 14.23%. That's 1 out of 7. You give me 2 decimal points with a sample size of 7. That's nonsense. But they're claiming accuracy they don't have. And then once you claim accuracy you do not have, I don't trust the rest of their data. So that's a problem. And then one sort of other just interesting thing is there are lots of things in this world that everybody knows. There's things that everybody knows this about this. This is a fact. The problem is there's no data to support that fact. And I know I used to work with Andy Spielman at Harvard, and he loved finding things that everybody knows but weren't true. Yes. So he would poke fun at these things, and we'd find that we would look at these and say, oh, yeah, no, that's not true. And we would design a study and show that it was not true. Just because everybody knows something, unless you have data to support that, does not mean that it is true. Now, unfortunately, you do the study to show that it's true or not, and it comes out to be true. That's really difficult to publish because you just proved that 2 + 2 = 4. No one's gonna accept that. There's nothing new there.
That is true.
But when you do 2 + 2 and you find out it really equals 5, and you've done it properly, it's, oh my God, our math is all wrong. And a bunch of stuff, we've changed some things in science that got changed because Andy had these crazy ideas about challenging things that everybody knows. Just because people believe it does not mean that it is true.
Absolutely. And now we are walking towards the edge of the conversation. I would like to know quick thought of the word of wisdom for the next generation of researchers from you. But before that, the biggest accomplishment of your research career, which you cherish the most?
I have no idea. I think part of it is not so much a single accomplishment. It's being recognized as someone who has contributed to the field, someone who is knowledgeable, someone who will listen to others. That I just got invited down to Panama because I met the person. I was in Costa Rica at a meeting, ran into a person from the Gorgas Institute in Panama who knew that I did studies in Peru about a virus he was interested in. And we were talking about the virus. And that got me invited down to Panama. It's having this network of people that recognize that I'm doing this because it's important. I'm doing this to make the world a better place. And that I realize that real quickly, people who know a little bit about something think they understand it. I know more about factors affecting the ability of mosquitoes to transmit viruses than almost anybody in the world. I am one of the world's experts. And I understand it. I don't understand it at all. I have enough knowledge to know that I don't understand it. There are so many things out there that I don't understand. But people who have a little knowledge think they understand it. To me, one of the big teaching points is just because you understand part of it, you don't understand all of it. The more you know, the more you realize you don't know. And so keep learning more.
This probably are the best word of wisdom we had in Researcher Celebrity. With this, we will tell to all the audience that you might have felt by now that Mike is a great mentor and he's there to help you. So if you want guidance, suggestion, comments, please write it to him. If you want us to help you, to bridge you with our researcher celebrities, we are there to help you. Just enjoy the research. And Mikey, thank you very much for motivating the next researcher generation and also to tell them what not to do. Thank you very much. It was a pleasure having you.
Thank you.